Hey guys, so today's video is about how to turn an NFA into a DFA, and it's actually a really simple process once you get the hang of it. And eventually, after you work through a couple more examples, you'll be able to do a lot of the computation in your head very quickly. But I showed the step-by-step process in detail for those of you who are learning for the first time. And if you guys have any questions about the video, then just comment below and I'll get to it in my free time. I hope you guys learned something from this video and enjoy watching. Okay, so here I have an NFA drawn which recognizes a language that I wrote over here as a regular expression. And the first thing we need to do in order to turn an NFA into a DFA is to first represent this NFA as a table, which I kind of already started over here. So in the first column, I made a row for every state from 1 to 6, and I also made a column 0 and 1 for every letter in the alphabet, since our NFA's alphabet is just a set 0 and 1. And I also made a column for epsilon because in an NFA you can transition from one state to another on an epsilon. So filling out this table is pretty quick and easy. We want to start off in our start state of 1, and from there we need to see on an input of 0 can we go to a different state. So on an input of 0 we can go to state 2, so I'm just going to put a 2 right here. And then on an input of 1 there's actually no arrow specifying that we can go from one state to another, so I'm just going to represent that as the empty set. And then there's no arrow for an epsilon directly taking us to a different state, but keep in mind that if you are already in one state and you're reading in an empty string, you would just remain in the same state. So we're just going to put a 1. And then we're just going to continue filling out this table in the same way. So in state 2, on an input of 0, we can go to 3. On an input of 1, we can go to 5. Epsilon, no arrow, so we stay in 2. 3, no arrow for 0, empty set. On an input of 1, we can go to 4, and we would remain in the same state on an epsilon. So for 4, there's no arrow with 0 and 1 taking us anywhere, so we're just going to put an empty set and an empty set. And on an epsilon, we can actually go back to the start state of 1, but also keep in mind that just like in our earlier 3 states, we could still just remain in the state 4 on an empty string. So I'm just going to write that as a set 1 and 4. So that we include both of them. Alright, so for 5, on an input of 0, we can go to 6. On an input of 1, we would just remain where we are. There's really no other state we can go to, so I'm going to put an empty set. And then on an epsilon, we can either go to the start state or remain where we are. Okay, so last one, there's no arrow for 0 and 1 taking us anywhere new. So I'm going to put empty set, and then as you can see we can go back to the start state or remain in the state we are currently at. And that is our NFA table. Okay, so we're ready to fill out our DFA table, and for the most part I'm just going to be keeping the same columns that I had previously in our NFA table. So we have this first column for all the states, and then we have a column for 0, and then we have a column for 1. But notice that I did not make a column for the epsilon because in a DFA you cannot transition from one state to another on an epsilon. And the main goal of making this table is to get rid of this column but account for the fact that it once previously existed. So you'll see what I mean as we continue filling out this table. But to start off, we're going to do a 1 as our first row, because we want to start in the start state as we did in the NFA. And we're just going to be cross-referencing this NFA table to see where we can go to on an input of 0 and 1. So in state 1, on an input of 0, we can go to state 2. But since we're going to get rid of this epsilon column, we also need to check in state 2, is there anywhere else we can go to on an epsilon transition? And it just says 2 again right there, so we're just going to put a 2. And then on an input of 1, we have the empty set, so I'm just going to put the empty set there. And now at this point we've introduced this new state to this DFA table too, and we need to see where can we go from this new state. So we check over our NFA table, and on an input of 0 we can go to 3. And we need to cross-reference and check that on an epsilon in state 3 can we go anywhere else. We're still in the state 3, so I'm just going to put the 3 right there. And then now on an input of 1 we can go to state 5. And now we need to check in the 5 row, is there anywhere else we can go to on an epsilon transition? And in fact, there is a set 1, 5, so we want to include that whole set. And note that it would be incorrect if you simply just checked this row and saw there was a 5 here and transfer that information over here. Because we need to take into account that the epsilon existed and you can move from one state to another on an epsilon. So now I'm going to see here that I introduced 2 new states, which is 3 and 1, 5, and I need to map out where I can go to at that point. Okay, so on a 3, we have the empty set here, so I'm going to put that. And then we can go to 4, check the epsilon. We see that we have a 1 and a 4. So we're going to move that over here. And then here we have a set, but we're just going to be following the same pattern. So on a 1, we can go to 2 from an input of 0. And we check the epsilon and it's still a 2, so we're fine. And then on a 5, on an input of 0, we can go to 6, and we check over here on an epsilon, we can go to 1 and 6. So we want to include that here. And I'm just going to rewrite this as a set in numerical order, so it's easier to keep track and organized. Alright, so 1, 2, 6. Now we're going to do the same thing on an input of 1. So go over here, check, we have an empty set, so we're just going to move on. We have another empty set, put an empty set. So at this point, we've introduced some more new states that we need to map out. So I'm going to make a row for all of those states. So we have the 1 and the 4, and the 1, and the 2, and the 6. Okay, so now on a 1, with this state on an input of 0, we can go to state 2. I'm just going to fill it out right here too. And then for 4, on an input of 0, empty set, so we can just leave this 2 by itself. And then let's see what happens on an input of 1. For 1 and 4, we have an empty set here and an empty set here, so I'm going to put that right over there. And then checking for 2 right here, on an input of 0, we can go to 3, and then on an epsilon, we'll just be in state 3. And then 6, on an input of 0, we have that empty set, so I'm just going to keep it to these 2 numbers, 2 and 3. Okay, now on an input of 1, we have this empty set here. For 2, we have 5, map over here, and we see we have the set 1, 5. And the last thing we need to check is the 6. On an input of 1, we have the empty set, so I'm just going to close this right here. Okay, so at this point, we've introduced this new state, 2 and 3. Okay, so let's see. On an input of 0, I can go to 3, and on an epsilon, I would stay in 3, so I'm just going to put that 3 right there. And then on an input of 0 in state 3, we have the empty set, so we're just going to leave this number alone by itself. And then for an input of 1, we can see that for 2, we can go to 5. We check over at 5, and we see the 1, 5 here. And what happens on an input of 1 in state 3, we can go to 4, so we check over here at the epsilon. And we already have 1 included, so we just need to put that 4, and I'm going to rewrite it as a set in numerical order. And at this point, we have 1 new state, which would be the one we added just now. So we have to map out the 1, 4, and 5. Alright, so on an input of 0, in state 1, we can go to 2, and we already know that the epsilon is still 2. On an input of 0, in state 4, we have the empty set. And on an input of 0 in state 5, we can go to 6, so we have the 1 and 6 on the epsilon. So this is actually going to be a set of 3 numbers, 1, 2, and 6. Alright, so we're just going to be filling out on an input of 1 now. So in state 1, on an input of 1, we have an empty set. In state 4, on an input of 1, we have an empty set. In state 5, on an input of 1, we have an empty set, thank God. Okay. So now we know that we do not have to add any more rows to this DFA table because we have not introduced any new states. So At this point, we have our completed DFA table. And filling out this table, like I said, was just a bit tedious, but once you get the pattern down, it's just a matter of going through all the states. So at this point, you can stop and begin writing your DFA diagram based off of this table. However, if you look at the table more carefully, there are a couple of repetitions that exist in some of the rows, and we can actually simplify this DFA table to be quite a bit smaller. So if you want to continue to see how that works, then keep watching the video, but just know that this DFA table we made is still totally valid, but there is a way that we can simplify it more and make it look cleaner. Here we have our completed DFA table from before, and I'm just going to be simplifying this table by scanning it for any obvious duplicates. So right now I already see that there's a duplicate in this first row with this row right here. As you can see, the state 1 and the state of the set 1 and 4 map to the same place on an input of 0 and 1. So there's really no need to have two of them. So I'm just going to be keeping this first state of 1 and getting rid of this state 1, 4. So I'm just going to be erasing this and keeping the first one. And in doing that, I also need to check that does this state that I just erased and got rid of, 1, 4, exist anywhere else on this table. So as we can see here, state 3 on an input of 1 maps to that state 1, 4 that I just got rid of. So I want to erase that and replace it with the 1, because between the two states 1 and 1, 4, we decided to keep the first state of 1. So now just scanning the table again for any obvious duplicates. I see that there's another one right here and right here, so I'm going to be only wanting to keep one of them. I'm going to keep the first one, so I'm going to get rid of this set 1, 4, and 5 because it's not necessary to have the duplicate. And again, double checking, does that state that I just erased appear anywhere else in the table? It's right here, so I'm going to erase this and replace it with the state we decided to keep between the two of them. Okay, so scanning again for any obvious duplicates. We've just created another one right here and here between the state 2 and the set 2, 3. So I'm going to be keeping this first row right here, the one that's higher above with the 2. So getting rid of the set 2 and 3, and then double checking anywhere else in the table does that set that we just erased exist. And we see that it appears again right here, so we want to get rid of it, and we know that between the two states we decided to keep state 2. So I'm going to be putting a 2 right here, and that's it. That's our simplified DFA. And now I'm going to be moving on to turning this table into a DFA diagram itself. As you can see here, I transferred our simple DFA table and wrote it again. And now we're getting to the fun part. We can now make the diagram for our DFA. So this is really simple. We're just going to be starting off at our start state of 1. And we already know from the diagram of our NFA that the start state 1 was an accept state. So we want to do a double circle for that one. All right, so now moving on, in the state 1, we need to check our table and see where can we go to on an input of 0. Well, on an input of 0, we can go to state 2, and on an input of 1, nothing interesting really happens, so we're just going to be leaving our table like this. And now that we're in state 2, we need to see where can we go to from 0 and 1. So I'm going to draw an arrow for 0 and 1 since we go to a different state for both of those inputs. And on a 0, we go to state 3. And on a 1, we go to state 1 and 5. So I'm just going to put a 1, 5 and circle that. And I want to put another double circle right there because since this set contains 1, which was our original accept state in the NFA, we also want to put a double circle around that. So anything that contains that 1, we want to put a double circle. Okay, so now let's see, where can we go to from state 3? Well, on an input of 1, we can go back to our start state. So I'm just going to draw an arrow back here and label it with a 1. All right, so now let's see. in this state 1, 5, where else can we go to? So we need to create this new state because on an input of 0, we can go to this state 1, 2, and 6. And again, like I said, you want to put a double circle because this contains a 1 in the set. And now let's see from this state in our table, where can we go to? So we can go back to the state 2 on an input of 0. And we can also go back to the state 1 and 5 on an input of 1. And that's it. That's our completed picture of our DFA that we created from the original NFA. So at this point, we are done.